Hi class, so from today, let's discuss the frame and the machines. So what's the difference between the frame and the machines? And what's the difference between frame machines and the trusses we discussed before? So for today's lecture, all the methods we discussed will be not new. So which means we'll be using the same method, like draw the free body diagram, solving the reaction, and then using the equilibrium to solve the internal forces as we did in the chassis. So those methods will be useful to solve the frame and the machines. So first question, what's the difference between the frames and machines? So in civil engineering, we usually use the term frame to describe a stationary and for the stationary structure which support external loads. But if you are majoring in mechanical engineering, so you domain usually use the term machine, which contains a moving part and designed to alter effect of the forces. Okay, so that's the difference between the frame and the machines. It's used in different area. And what are the difference between the frame machines and the trusses? So if they are the same, we don't need to attend to this lecture. There are definitely some differences, but what's the difference between frame machine and trusses? So for the trusses, we only have the two force members. Okay, how many of you still remember what are two forces members? So in trusses, all the members, it will be either comprise of tension, it's a two forces member. And for example, so the figure showing here is a frame. If we draw the point, all the forces and joint C, okay, we have one external force, an FCA and an FCB. And for the point A, we have two external force AX and AY and FCA. So member FAC has two forces, FCA on A point and joint C. So those are all the similar thing for member AB and BC. So those are all two forces members. For the frame and machines, okay, so they are usually a pin, okay, when the forces are equal as the opposite. So which means in a frame and a machine, we usually have a pin to connect two sections or even more pins to connect more sections into one frame or machines. We will see an example later. So if I give you the frame, how to solve the frame? Okay, here are the steps we used before. We can leverage the same steps. So first you need to draw a free body diagram of the frame, and it's usually separated at pins. Okay, and also the unknowns and the pins are equal to the opposite, and opposite in each free body diagram. So after we finish the free body diagram, you can apply the equation of the equilibrium. So just to refresh your memory, the three equations of equilibrium is first one, sum of the moment on any point equals to 0. Second one, sum of fx equals 0. Sum of fy equals to 0. So we use the three equations of the equilibrium to solve the forces. And usually start at the external force and work back on the other side. So that's what we did for the joint method and cross-section method for the chassis analysis. We usually start with the external forces. So well, let's see, without further discussing how to solve this problem, let's see an example. So we have kind of structure. So we have member AB and BC. Is this a truss or is this a frame? Okay, so the answer should be frame because at joint point B, it's connected by a pin. Okay, so that's a definition of the frame we discussed before. So here's the frame, supports external force as show and movement as show, and also please find the horizontal and the vertical component of the pin reaction and A and C, and the magnitude of reaction B. Okay, how should we solve this problem? So first, let's draw a free body diagram of BC. Okay, let's see here the BC. Point C is a pin. Okay, we have CX, CY, and also we have 400 Newton here. And point B, okay, so we have force FAB, which is in the direction of member AB. So the slope of the member AB is 1/3. Okay, and also let's label its dimension. So it's 1 meter. Here is also 1 meter. Here is also 2 meter. Okay. So how we need to decompose it? Okay, we need to decompose it the FAB into FABX and FABY. So FAB (3.16) and FABX equals to 3/3.16. Okay, each 0.95. FAB. FABY will be 1/3. Which is 0.16, okay, of times FAB. And then, okay, we can apply our 3 equations. Okay. We have B, we have C, we have force 400, we have CY, we have CX, FABX, FABY. This is 1 meter, 1 meter, and a 2 meter. Okay, let's do sum of the MC equals to 0. Okay, which will be 400 times by 2 meter plus 8 Newton, 800 Newton meter, which is positive, minus FABY times 3 meter minus FABX times 1 meter, which equals 0. So the equation will become 800 Newton meter plus 800 Newton meter minus 0.316 FAB times 3 meter minus 0.95 FAB times 1 meter equals to 0. So we can solve, okay, just use a calculator, we can solve FAB equals to 483. Okay. And our second equation sum of the fx equals to 0. Okay, we will have cx minus abx equals to 0. Okay, Okay, we only have two forces on the horizontal. So Cx then equals to 800. And the direction, because it's positive, the Cx its direction is same to our assumed direction. The third equation, sum of Fy equals 0, 400, which is negative, plus Fab y plus Cy equals to 0. Negative 400 plus Fab times 0.316 plus Cx equals to 0. We can solve Cy equals to 133 Newton, and its direction is positive. Okay, so we solve the member BC. As we discussed before, we also need to solve the other part, okay, which is part AB, and the unknown at the pins, they are equal and opposite in each FBT. So we already solved FAB, which is this number, and the FAB on member AB will be the same, but just in different direction, okay? Here is a member AB. And the same, we can decompose it, FAB into FABX, FABY, AX, and AY. And the height, 1 meter, the width is 3 meters. So our first equation, okay, and again, you can see that FABX, FABY, its direction on member AB is just opposite in its direction on member BC. Okay. Our first equation, here we don't have to start with sum of the moment equals 0. We can just write sum of x equals to 0, which is AX plus FABX, okay? So I will assume AX is this direction, equals to 0. And what's FABX? We already solved it. It's 800 equals 0. AX is negative 800, which means our assumed direction is opposite. Sum of Fy equals 0. AY minus FABY equals to 0. FABY is, we already solved it, it's 266.4. AY is this number, and it's positive. Okay. Until now, we solve all the problems. Okay, we solve all the forces for both sections, for both parts. Okay, any questions so far? You can pause this video a little bit before we move to example 2. Okay. So example 2, we have composite beam, which is pin supporting B and has a roller supporting A. If zero the hinge and D, find the reaction for all the supports. Okay, so it's given. We have composite beam. A is roller, which means we will have AY. BY, BX, because B is pin, and C is also the roller, we only have CY. So how to solve this problem? So we can cut this up structured point at a pin D. Okay. After the cut, we have two sections, left section and right section. Okay, let's draw the forces. On the right section, we have AY, we have BX, BY, and also we have DY, DX. On that side, we also have dy and dx, okay, which is negative, which is just opposite direction of the dx and dy on part AD, okay. And also we have cy. So like what we did for the method of the section, we should start with a section with less number of the structures and what? And the forces. So which means let's get started with a section, red section, okay? And we also need to convert a distributed load, okay, into single loads. It will be this equation times by 3 meters, 6 kilonewton. We have cy, dy, dx, okay, and this distance is 3 meters. Okay, the total distance is 3 meters. This is just a half, 1.5, 1.5. Okay, you can pause this video a little bit and calculate or do the same thing for the other part. Okay. Okay, here's the answer. After the conversion, the single force should be 18 kilonewton, and its distance is 4.5 meters from point A and D. So, as we discussed, let's analyze the right side first. Cy 6 Newton, dx, dy 1.5 meter. Our first equation, sum of the moment equals to 0 and point C, we can get 6 kilonewton times 1.5 meter, which is positive, plus dy times 3 meter equals to 0. We can solve dy is negative 3 kilonewton. sorry, this should be negative because the dy is clockwise movement. It should be the positive. Okay, sum of the Fy also equals 0. 3 Newton minus 1 second. Three Newton, which is dy, minus 6 Newton plus cy equals 0. Cy equals to 3 kilonewton, which is positive. Okay, and we can circle the answer. And also, sum of the Fx equals to 0, which is dx. Okay, we have nothing but dx in the x horizontal, which just dx equals to 0. Well, then we can analyze the left side. Okay, so we have ay, by, bx, okay, and we have 18 Newton. And also we have true force dx equals 0, dy equals to 3 kilonewton, okay? The magnitude is the same, it's just in a different opposite direction. Sum of the F moment, okay, sum of moment on point A, 0, which means negative 18 kilonewton times 4.5. So this one is clockwise, which is negative. By is counterclockwise, which is positive, times 6, and minus dy, okay, which is clockwise, which should be negative, equals to 0. And we can solve by equals to 18 kilonewton. Okay. Then sum of Fy equals to 0. We can get Ay minus 18 kilonewton plus By minus dy equals to 0. By is 18. Ky is 3. We can solve Ay equals to 3. Okay. Sum of Fx equals to 0. Bx plus dx equals to 0. Because dx is 0 already, By is just 0. Okay. Let's see your attention quiz. Suppose, okay, we have this figure showing this structure. You have already drawn the free body diagram of BC. Okay, let's draw it together. We have BC, and in force we have CY, CX, FAB. We have 400 lap, 500 lap. Okay, which equation we can use to solve at B? Which is the easiest way to solve the unknown at B. Okay, so sum of the moment and point B. If we use this equation, we can solve the CY very quickly. Okay, but if we use the sum of moment on point C equals 0, we can solve the FAB very quickly. sum of fy equals to 0, we can solve nothing because we have cy and faby, they are two unknown. We cannot solve anything by using this equation. So to solve the unknown and b, we should use the equation a at first. Okay, this is a little bit long lecture because we use all the methods we learned before to solve the pins. Okay, hopefully you can please do the homework. Let me know if you have any questions.